Here is the next example. Here he's asking us to find VA by using nodal analysis. So we know that as long as there are more than one source, definitely we need to solve it by using either nodal analysis or mesh analysis. So in the question itself, most probably it will definitely explain find VA by using either nodal or mesh, but here I'm clearly asking you to solve it by using nodal analysis. So we are looking for solving it by using nodal analysis. What is the first step in nodal analysis? Find all the nodes. Okay, so here is one node V1. Let me label this as V2, V3, and V reference. Okay, the next step is we always chose V reference as 0, reference node voltage as 0. So if I know the reference node voltage, and now nodal analysis is nothing but applying KCL, Kirchhoff's current law, at each node. Okay, now before applying KCL at each node, look at each node and see if there is a voltage source between reference node and unknown node voltage. So if you look at V1 and V reference, so here is my V1 and the given voltage is 120 volts. V reference, this value is 0. Can I say V1 minus V reference, which is 0, equal to 120 volt? This value must be equal to 120. I know V reference is 0, so V1 must be equal to 120 volt. Same way, what kind of source is this? This is a dependent source. Whenever you see a rhombus, definitely that is a dependent source. If you have plus and minus inside it, that's a voltage source. Now this voltage source is depending upon what? VA. What is VA? VA is the voltage. So this is a voltage dependent voltage source. Okay, so another example, say for example you have something like this. Here you see the arrow inside. If there is an arrow inside, that is a current source. Rhombus indicates that that's a dependent source, but this is a current source. It is depending upon what? VA. VA is the voltage, so it's a voltage dependent current source. Okay, so the given source is a voltage source. Can I say V3 minus 0 equal to 2 VA? Another one. So without applying KCL, I already found this value as 2 VA, this value as 120 volt. Now V2, can I say V2 equal to same as VA? V2 must be equal to VA. Okay, so I can label this as VA, but to avoid confusion I label this as V1, V2, V3. Now I made it equal to VA because you can clearly see you have a 6 ohm resistor and you're saying the voltage across this is VA and voltage is 0. You're taking this as V2. So can I say V2 minus V reference, which is 0, equal to VA. So V reference is equal to 0. So V2 equal to VA. Okay, so instead of calling them V1, V2, V3, now I found this value as 120, this value as VA, and this value as 2 VA. Now at VA apply KCL. Okay, let me erase part of. Now what I'm doing applying KCL at VA. As usual, I always chose every current is going out of the junction. So I1, I2 and I3. So I1 plus I2 plus I3 equal to 0. I'm applying KCL at VA. Apply KCL at VA. So I1 equal to V2 minus 120 over 3. I2 equal to V2 minus 0. So instead of V2, I'm going to take that as VA. VA minus 120, VA minus 0 over 6, because I just defined VA equal to V2, plus VA minus 2 VA over 9 equal to 0. So to eliminate the denominator, I'm going to multiply this with 9. So 3 VA minus 360 plus 1.5 VA plus VA minus 2VA equal to 0. So 3VA 4.5, 5.5 minus 2. So 3.5 VA equal to 360. So VA equal to 360 divided by 3.5. This value is 102.85 volt. Okay. Once I know VA, I can find current flowing in the 3 ohms because all I need to find I1. I mean, in this case, he's asking for VA only. I'm done finding the final answer. But say if he needs you to find something else like I1 is nothing but VA minus V1 over 3. So I have VA as 102.85 minus 120 over 3, that equal to, this value is minus 5.71 ampere. So basically, whenever you see this negative, I chose I1 is flowing from V2 to V1, but in reality it is flowing in the opposite direction. So that's the reason you have negative. So basically 5.71 ampere current is coming in this direction. Now let me find I2 equal to VA over 6. So VA is 102.85 over 6. That current is 17.14 ampere. So I have positive current, so that current is going in. Now let me write down I3 equal to can I say I3 is nothing but V2 minus V3 over 9. V2, or I can say VA minus 2VA over 9. So basically it is minus VA over 9. What is VA? Minus 102.85 over 9. That value is negative 11.42 ampere. So negative indicates that current is entering. So here it is 11.42 amperes current is entering and 17.14 amperes is leaving. So you can clearly see basically 5.71 is entering, 11.42 is also entering, must be equal to current leaving 17.1. So this is, so we verified the Kirchhoff's current law. Our goal is finding VA in this question. I found VA, but I also found current passing through each resistor in this example. Thank you.